Operating a pulp mill efficiently requires more than training in how to use the controls. Making the best operating decisions means that you must know how the system works and why it works. Batch digesters with all the surrounding pipes, pumps, tanks, and valves reveal little of what is happening inside. Animated graphics can help you to understand their inner workings. Batch digesters are large vessels, commonly constructed of mild steel. They have cylindrical bodies, joined to a cone-shaped bottom section, and either a dome-shaped or cone-shaped top section. Digesters could be described as giant pressure cookers. Inside, wood chips and cooking liquor react under high pressure and temperature to produce pulp. There are two types of conventional batch digesters: those equipped for direct steaming through nozzles in the vessel walls, and those equipped for indirect steaming. Indirectly steamed digesters require extra equipment. Strainer plates, forming an internal band around the digester's midsection, are used to extract cooking liquor, which is then circulated through a heat exchanger and back into the digester. There may also be an air evacuation system connected to the strainers. In batch cooking, the digester vessel is filled with chips and cooking liquor. Heated according to a precise time temperature profile, and then emptied or blown to a blow tank. The cycle is repeated, and the blow tank fills with pulp. Let's take a closer look. Filling and packing a digester with chips and liquor is called charging. There are several methods of charging a batch digester. We will start with the most basic method, gravity filling. With gravity filling, the chips falling unaided into the digester vessel tend to form a mound in the center. This may result in uneven distribution of chips throughout the volume of the digester and produces the lowest overall density among chip packing methods. To counteract this effect, some systems have devices in the necks of the digesters, which swirl the chips uniformly outwards towards the digester walls. More even distribution results in better compaction of the chips inside the digester. The device, called a steam packer, uses a ring of steam jets to blow the chips radially outwards as they fall into the digester. A bonus of steam packing is that moistening and warming of the chips occur simultaneously, aiding subsequent impregnation of cooking liquor into the wood. Displaced air is evacuated through the circulation strainer plates, instead of through the top of the digester, as in other chip packing methods. An air evacuation line is connected to the liquor circulation line. A fan draws the displaced air and some steam through a cyclone separator to remove any fine wood particles before discharging the air and steam to atmosphere. In some digesters, low-pressure steam is injected into the bottom of the digester during chip filling. This technique warms the chips and displaces air, which aids subsequent impregnation. Continuing to inject steam into the bottom of the digester heats the chips to about 100 degrees Celsius. The chips are then said to be pre-steamed and ready for the addition of white and black liquors. Measured amounts of white and black liquors are pumped into the top of the digester. The temperature of the liquor plus chips is approximately 90 to 100 degrees Celsius. A common method of charging a batch digester is known as liquor packing. The liquor, a combination of white and black liquors, is pumped into the neck of the digester as the chips fall into the vessel from the chip chute. White liquor provides the alkali required for cooking. Black liquor is used to ensure that the chips are completely covered and wetted. The combined liquor lubricates the chip surfaces and allows them to pack fairly well, increasing the charge in the digester by about 10% over gravity filling. With liquor packing, the displaced air normally passes out through the open digester top. The digester capping valve is then closed, and the chips and liquor are ready for heating and cooking. Pause the tape now and review your training manual, or proceed to the next section. There are two methods used to heat conventional batch digests: direct and indirect steaming. In the direct method, steam is injected into the bottom fitting of the digester, or via nozzles in the cone section, increasing the temperature and pressure. Direct heating is monitored by temperature sensors in the digester wall. A preset time temperature profile is attained by manual, computer, or cam control. Indirect heating usually provides a more even temperature distribution throughout the digester, but requires extra piping, a heat exchanger, and a liquor pump. When there is sufficient liquor above the strainers or at the end of the liquor charging, the liquor circulation pump is started. The heating is controlled by the amount of steam supplied to the liquor heater. When the temperature exceeds 100 degrees Celsius, the pressure in the digester starts to increase. A top relief valve is used to control the venting of air and gases from the digester vapor space. The time required to heat a typical batch digester to cooking temperature may vary between about 40 to 120 minutes, depending on the grade of pulp being produced. The maximum temperature is usually in the range of 165 to 178 degrees Celsius. And the maximum pressure is between 655 and 725 kilopascals. High temperature enhances the reaction of alkali with lignin, dissolving most of it in the cooking liquor. At the same time, some of the cellulose and the hemicelluloses are also dissolved. Typical total cooking times are between 60 and 240 minutes, again depending on what kind of pulp is being made. When should the operator terminate the cooking? A mathematical expression which combines both time and temperature, the H factor, is commonly used for this purpose. When sufficient cooking or delignification has taken place, the blow valve in the blow line is opened. In conventional hot blowing, the contents of the digester are blown to a blow tank, entering tangentially at the top. The pressure of the mixture drops quickly, which causes steam to flash off. The steam is drawn off to a blow heat recovery system, and the mixture of pulp and black liquor accumulates in the blow tank. An agitator in the bottom of the blow tank mixes the pulp and black liquor. The suspension is pumped continuously to the brown stock processing line. When the blow is over and residual steam has been evacuated from the digester, it is ready for the next batch cook. To review, let's follow the various methods of performing a conventional batch cooking cycle. First, the digester is charged with chips and liquor. In gravity packing, chips are added first. Alternatively, a steam packer may be used to increase the chip charge. Or steam may be injected into the bottom of the digester during chip filling to displace air and aid subsequent impregnation. Pre-steaming brings the chips to about 100 degrees Celsius. White and black liquors are then added. Simultaneous chip and liquor filling is called liquor packing and is a common alternative to the steaming of chips prior to liquor addition. Heating can be direct through steam injection into the digester, or indirect, using a liquor heating and circulation system. The mixture of chips and liquor is heated and cooked according to a precise time temperature profile, usually under automatic control. In hot blowing at the end of cooking, the blow valve is opened and the digester contents flow to a blow tank. The digester, once empty, is charged with chips and liquor for the next cook. Understanding how and why the system works lets you make the best operating decisions for safety and efficiency. To fully understand the process, we suggest that you review this tape using the Craft Pulping module as your reference guide. Operating a pulp mill efficiently requires more than training in how to use the controls. Making the best operating decisions means that you must know how the system works and why it works. A digester, with all the surrounding pipes, pumps, tanks, and valves, reveals little of what is happening inside. This program will use animated graphics to show you some of the processes going on inside a typical continuous digester system. The Kamyr single-vessel hydraulic digester system produces pulp in a continuous process. The digester vessel could be described as a giant pressure cooker in which wood chips and cooking liquor react under high pressure and temperature to produce pulp. The process is a continuous one. The pre-steamed chips pass downward through a number of zones and exit as pulp. Interacting with the digester are liquor circulation loops, steam heating systems, and the chip and liquor feeding system. In this system, the chips are steamed, combined with white liquor, and are brought to full digester pressure. Let's look at these processes in more detail. Following screening and magnetic separation of tramp iron, the chips pass through the airlock feeder and enter the chip bin. Chip bins are often equipped with steam nozzles for atmospheric pre-steaming. The chip bin activator discharges the chips into the chip meter. The chip meter discharges the chips into the low-pressure feeder. The low-pressure feeder receives the chips at atmospheric pressure and delivers them into the 20 psig of the steaming vessel. The chips are moved horizontally through the steaming vessel by a slowly rotating screw. Steam comes in through the underside and exits through the top steam outlet. Steaming saturates the chips with water vapor, enhancing the penetration of the white liquor during impregnation. After traveling the length of the steaming vessel, the pre-steamed chips drop into the chip chute. As they enter the chip chute, they meet with white liquor. The chips and white liquor descend the chip chute towards the high-pressure feeder and may pass through a tramp material separator, found more often in newer systems. Pause the tape now and review your training manual, or proceed to the next section. The high-pressure feeder transfers the mixture from the low-pressure system to the high pressure of the digester vessel. This high-pressure feeder is an interesting piece of engineering design. We'll open this model to show how it works. A plug, equipped with 4 offset pockets, rotates in a housing. The 4 pockets are arranged in 2 pairs. Each pocket curves past its partner, providing an uninterrupted channel through to the other side of the plug. As the plug rotates, each pocket alternately aligns vertically with the chip chute system and horizontally with the digester top circulation system. This design maintains the pressure difference between the low pressure of the chip feeding system and the high pressure of the digester vessel. As one pocket moves out of alignment, another comes into alignment, providing a continuous flow of chips and white liquor to the digester. In this side view, you can see that the plug and its housing are tapered. By moving the plug on its horizontal axis, the clearance between these components can be adjusted. Correct adjustment of the clearance provides controlled leakage of white liquor around the plug and up into the chip chute. This liquor lubricates the unit, and its leakage introduces white liquor to the chips in the chip chute before they enter the rotor pockets. The top circulation pump flushes out the pockets as they align horizontally, driving the chip and liquor mixture to the top of the digester vessel. This mixture is now at the high pressure of the digester vessel. A rotating screw in the top separator moves the chips and liquor down into the digester. Surrounding the screw is a cylindrical screen with vertical slots. These slots allow excess transport white liquor to pass through while retaining the chips. This transport white liquor returns to the high pressure feeder via the top circulation loop. This is one of the many liquor circulation loops in a Kamyr digester system. Before getting into the digester operation, let's review the chip and liquor feeding system. The areas will be highlighted as they are described. Feel free to pause the tape at any point and look at the training module. Screened and prepared chips enter through the airlock feeder into the chip bin. Some chip bins have atmospheric pre-steaming. The chip bin activator helps the chips fall into the chip meter. This unit controls the digester production rate. It discharges the chips into the low pressure feeder, which delivers chips to the steaming vessel at about 20 psig. Here they are steamed to remove air before dropping into the chip chute. The chip chute is where they meet the white liquor. The mixture then drops into the high pressure feeder. This is where the mixture is increased to the high pressure of the digester vessel. The top circulation pump flushes out the horizontally aligned rotor pockets, driving the chips and liquor to the top of the digester vessel. A screw in the top separator propels the mixture down into the vessel. Screens surrounding the screw extract the free white liquor. This liquor returns to the high-pressure feeder via the top circulation piping loop. There it is, the chip and liquor feeding system. Review this section, pausing to refer to the training module. Or if you feel ready, proceed to the digester. Inside the digester, the chip and liquor mixture moves downwards from the top separator through a succession of processing zones. The impregnation zone, the heating zones, the cooking zone, the quench zone, the liquor extraction zone, the washing zone, and the cooling and blowing zone. Let's look at these zones in more detail, starting with the top separator. A rotating screw in the top separator moves the chips into the impregnation zone. The chips move down through the impregnation zone for approximately 45 minutes at a constant temperature of about 125 degrees Celsius. This is where the white liquor penetrates into the chips. It doesn't yet remove the lignin from the chips. The temperature isn't high enough. Moving downwards, the impregnated chips enter the first of two heating zones. Strainers with vertical slots form bands around the inner wall of the digester. These slots, typically 5 to 9 millimeters wide, allow liquor to pass into a hollow ring behind the screens. The liquor is sucked out through these strainers by a pump and sent to a heat exchanger. Here, high-pressure steam indirectly heats the liquor to a temperature high enough for lignin to be removed, typically between 150 and 160 degrees Celsius. The liquor, heated to the desired level, returns to the top of the digester and enters one of a series of vertical concentric pipes suspended down the center of the cylindrical vessel. These pipes return cooking and washing liquors to the same zones that they were extracted from, without impeding the downward movement of the chip mixture. For each of the zones, the liquor re-entry point is located slightly above the extraction screens to provide a uniform outward radial flow. With constant suction of liquor, the slots would quickly plug with chips. So the circulation lines from the strainers are switched on and off about every 90 seconds. While one strainer is extracting liquor, the other is being wiped clean by the steady downward movement of the chip plug. The upper heating zone system is only one of the Kamyr digester's many circulation loops using a central pipe and annular strainers for liquor removal. The lower heating zone system works the same as the upper heating zone, but heats the chips higher to between 160 and 170 degrees Celsius. A third heater is connected and valved as a spare if either of the other two heat exchangers break down. After the two-stage heating process, the mixture now at between 160 and 170 degrees Celsius moves steadily down through the cooking zone. Here, the alkaline liquor continues to react, primarily with the lignin, but also with other wood components. The reaction products dissolve in the cooking liquor. These reactions create additional heat, raising the temperature another 1 or 2 degrees Celsius. 90 minutes is a typical time in the cooking zone. Cooking is stopped by removing some of the hot cooking liquor and by cooling and washing in the lower digester zones. Warm wash liquor is pumped into the bottom of the digester and forced upwards against the downward movement of the chip column. The area where they meet is called the quench zone. But if we have wash liquor being pumped into the bottom and white liquor and chips going into the top, something has to leave the digester. The extraction zone is where the hot and cool spent liquor flows out of the digester through more slotted strainers. The extracted liquid is called black liquor. Its temperature is about 150 to 160 degrees Celsius. Most of the black liquor goes to a pair of flash tanks. Here the pressure is released, causing steam to blow off or flash. The steam from the number 1 flash tank is used in the steaming vessel, and the lower pressure steam from the number 2 flash tank is, in some mills, used in the chip bin for atmospheric pre-steaming. The black liquor from the flash tanks is sent to the recovery system. Some of the extracted black liquor is pumped to the top of the digester and returned through one of the concentric pipes to a point just above the extraction zone strainers. This is called the quench flow circulation system. It helps maintain a uniform horizontal temperature at this level in the digester. Near the bottom of the digester, there is in some installations a wash circulation system. It has a heat exchanger for heating and cooling the wash liquor as required. From the heater, the wash liquor flows down through the longest of the concentric pipes to complete the circuit. At the bottom of the digester, the cooked chips are continuously scraped from the chip plug by a pair of rotating arms and diluted with the cooler wash liquor before passing into the outlet device. The washed and cooled material becomes pulp as it is blown at a controlled rate to the external washing system. Let's return to the top of the digester vessel and follow the chips and liquor down once more. The impregnation zone is where the white liquor penetrates the chips. 45 minutes of retention time and 125 degrees Celsius are typical conditions. The upper and lower heating zones use heated circulating liquor to increase the temperature to about 165 degrees Celsius. The bulk of the lignin is removed during the 90-minute retention time in the cooking zone. After cooking, black liquor, formed by white liquor reacting with the chips, is extracted to a pair of flash tanks. Simultaneously, wash liquor is pumped upward through the washing zone to cool the cooked chips and stop the delignification reactions. At the bottom of the digester, cooked material is scraped from the bottom of the chip plug. It is diluted with wash liquor and is blown to the washing system as pulp. As you've seen, the Kamyr single vessel continuous digester system is fairly complicated. Understanding how and why the system works lets you make the best operating decisions for safety and efficiency. To fully understand the process, we suggest that you review this tape using the Craft Pulping module as your reference guide.